last day of looking into calculus, and I have finally decided that gaining deep understanding of the area problem was too big of an undertaking. So, um, the reason I went there in the first place is because of this book that I've been working out of for pre-calculus, and that is the section of this 12.5 discusses it, and it discusses it in terms of summations and like the limits of a summation. And I actually like to tell my students, so in Algebra 2 in the district where I work, they do summations of series, right? Which this is related to that. Some of this is exactly that. And the sum of an infinite geometric series, you have to have a rate that is between -1 and +1, not equal to those. Has to be absolute value less than 1. And I tell my students, like, this is the first calculus that you're doing, which is cool, right? This is the first kind of, because what that ultimately finds is the area under the curve. You are adding together every single thing under there as it approaches a value. And like, that is cool. It's the first bit of calculus, related to it. And so that is awesome. And this starts out talking about some of these summation problems that I do know and recognize and understand, right? And then it gets intense and bonkers, where I'm like, okay, so I get this first part completely, and then from there, I get confused. But here's a good thing. I do understand what the area problem is and how it relates to the tangent problem in terms of, approaching zero, so that line is accurate, so that the area under the curve is accurate. I watched a video on the fundamental theorem of calculus, which is talking about, you have a derivative and you have an antiderivative, and that there's a lot going on in that, which I sort of understood, but not enough to explain it to you. So yeah, I dug into something new. I tried to figure it out, but I thought, as I was exploring, wow, this was way too much of an undertaking to actually gain instrumental. Nope, that was the wrong one. Relational understanding. It's too much. And if there had been some kind of video that related to this specific lesson in this specific book, I would have watched that. And maybe that is back in pre-calculus or algebra 2. Maybe that's where that is. But it does say, all right, so I'm going to read this from the book. The problem is to find the area of a region, capital R, bounded by the graph of a non-negative continuous function f, the x-axis, and the vertical lines x equals a and x equals b. So that's that's in the fundamental theorem of calculus, and that is integrals, which I didn't get into at all. Limit of a summation. The limit of a summation. The strategy is to use a collection of rectangles that approximates the region. So that part I understood too, because I talked about that in a previous day. I even have the drawing of that in my book here somewhere. Here's my book. Here's my angle thing that I talked about when I did that, the area under a curve. So this just gets really dense, but I think it's good that I understand the two main problems of calculus, being the tangent problem and the area problem. And maybe I will get to the point where I solve these someday, but I promised I was going to do this, and I did, kind of. So here we are. Actually, this is our last day of derivative exploration, And I think that I gained some good understanding. That cliff that I of knowledge, of mathematical content knowledge, that I felt like I had just whoop, dropped off of there. I don't feel like it is anymore. I feel like we have a gradual descent into not knowing things. No, but this is good and this is important. So I understand the concept of a derivative. I know how to do a limit as something approaches something else. I understand the concept of limits. I understand how the sum of an infinite geometric series gets you to the area under a curve. So I've learned a lot. I've learned a lot of things. And I also learned that teaching yourself something is difficult but still possible. Thank you so much for joining me on this journey. I hope all of you enjoyed my ridiculous videos as I tried to be like, crikey, there's a derivative out in the wild. Right, that was a terrible Australian accent. Let's see if I can get David Attenborough this time. Off to the right, you shall see. No, because I just want to be soft and then I can't be British. I'm still a Steve Irwin and not a David Attenborough. And I think that's the real lesson here.